back. So, 8-1. This is the chapter that's going to go quickly. This is the chapter that you all should do pretty well at because we've already done most of it. So we've laid down all the groundwork and everything. This entire book actually leads to chapter 8, which is kind of weird. This first one, and I think it's just quadratic, what do they call it? Just quadratic equations, yeah.
By the square root property.
Yeah. They separate out a little bit. You have to be very good at these things. Even though they're at the end of the book, they are extremely important for the rest of math. Everything, any math topic you go from here on out will always have some kind of quadratic equation built into it in some fashion or form. So to learn how to do it well and do it properly the first time around will save you a lot of headache later on, especially in, Math 161, which this thing crops up more often than you want it to. The first thing we're going to deal with is solving by square root. This only works if there is a perfect square equation. There's different ways of solving a quadratic equation, and one of them is this. I'm going to show you, let's see. You've already learned how to solve these by factoring, but we'll come back to that again. We're going to do it by the square root method. Then we're going to do completing the square. And then we lead into the quadratic formula, which you all love to hate. And then it becomes a lot of everything. So the hard part is determining which way you should do it. Usually the general rule is to get it equal to 0, but that doesn't work with perfect square ones. So the property we're going to use for this problem is if x squared, I should put the word if in here, if x squared is equal to a, then x is equal to positive a, I should put the word or, negative a. And I can use a number example just to show you that this property actually does work. For instance, if I have x squared is equal to 9. I have x squared is equal to 9. Then, by this property, x is either equal to, put a square here. If x squared is equal to a squared, then x equals a, or x equals negative a. Okay. So, x is either equal to 3, or x is equal to negative 3. Why are we getting two answers? Well, if I take positive 3 and I square it, I get 9. And if I take negative 3 and I square it, I also get 9. Just make sure you put it inside of parentheses before you square it on your calculators. So this property is actually kind of cool. It helps us solve simple equations like x minus 2 all squared is equal to 7. Sure, why not? Let's be something ugly. What can I do to both sides? Well, technically what we're going to do is what's really going on here. What did I really do to the 9 to get to 3 and negative 3? Square rooted them. I square rooted both sides. So technically what's in the background is you're going to square root both sides of this equation. But once I do that, I'm changing some things. Instead of having one equation, we're really going to have two. And the only difference in it is one of the answers is positive and the other one is negative. So a quick way of writing this would be to say x is equal to plus or minus 3. And it's a new type of symbol. And you can write it in either order, plus or minus and plus. It really doesn't matter. But most people write it plus minus. And it represents both answers in one little, concise area. It's a positive 3, but it's also negative 3. Or I should say, or negative 3. So when I break this down, what happens when a square root hits a square?
You kick out the x, y, and
They
z.
pretty much poof and go away, and you're left with what's on the inside. You get a better explanation of that in college algebra, why it happens, but for now, it goes poof. On the other side, can I break down the square root of 7?
Yeah, we got a calculator.
Well, yeah, you can get an approximation. I want an exact answer. Leave it alone. Square root of 7. But in front of it has to go plus or minus, because you have to account for both possible answers. So it's plus or minus the square root of 7. How do you solve for x? Add 2. And generally what you do is you put it in front of the plus or minus, not after the square root of 7. So you're going to get x is equal to 2 plus or minus the square root of 7. Now this, again, is just shorthand notation. All it is shorthand notation. What it really represents is x is equal to a solution set, because there are 2 answers. The first answer is 2 plus the square root of 7. The second answer is 2 minus the square root of 7. Square root of 7 is someplace between 2 and 3.
So you take the first part, or we need the second part?
Well, the first part is a shorthand notation, but a lot of people don't understand that you have to really separate it. So I'm going to separate all mine. And I'm not sure what the computer does. I'm quite sure they separate it. They don't allow you to do plus or minus. Oh, well. And the reason for that is because some problems can actually find that square root. That one I kind of forced to be unsquare rootable. Not a perfect square. But what if we had something like, let's make it worse. X plus 4 all squared minus 5 is equal to 11. This is a perfect square equation. Why? Well, all the x's are buried underneath this perfect square. The other stuff on the outside is just a bunch of numbers. So if you have this situation where x is buried in a perfect square and it's nowhere else in the equation, it's considered a perfect square equation. So your idea here is pretty much the same as square root equations. You want to isolate the perfect square. So how do I isolate the perfect square? Add 5 to both sides. So we get x plus 4 all squared is equal to 16. Okay. What do I do to both sides? Square root. We have this perfect square on this side, so we're going to square root both sides. When it was a square root equation, we would square both sides. So what happens to the square and the square root? They go poof. Don't say cancel. Cancel implies inverse identity. But this is not inverse identity. They just go poof. So x plus 4 is equal to plus or minus. That's more important than the answer. The plus or minus is actually more important than the answer on the other side. Most people can get the answer. It's that plus or minus they'll forget. And then what do?
Subtract 4 from both sides.
So you get x is equal to?
Plus or minus 0.
No, you get
0.
negative 4 plus or minus 4. Write it all out. Because it's not 0.
What happened?
I move the 4, subtract 4 from here, subtract. Oh, you're trying to subtract 4 from that. Yeah. I'm not sure if that's a positive 4 or a negative 4, so leave it alone. And just write it out as negative 4 plus or minus 4. You can't get rid of it. You cannot. It's not positive 4. It's not negative 4. It's both of them at the same time. So you have to write it this way until you separate it. To simplify that, you need to separate it. Just like this one over here. This was 2 plus or minus the square root of 7. So you went 2 plus the square root of 7, 2 minus the square root of 7.
I don't think this stuff works.
It does.
It does.
It does. Negative 4 plus 4. That one's 0. Negative 4 minus 4. Negative 8. So the two answers to this problem are 0 and negative 8.
Oh, hold on.
What?
You just lost me.
How? Okay, come back over here. This is x equals 2 plus or minus the square root of 7. Yes?
Yeah. Okay.
So one of my answers was 2 plus the square root of 7. And the other answer was 2 minus the square root of 7.
Yeah.
So over here, negative 4 plus 4, which is?
Oh, so you go ahead and subtract.
Yeah, I can.
Yeah. Okay.
Over here I couldn't do it because I had a rational number and an irrational number. But these are both rational. So negative 4 plus 4 is 0. Negative 4 minus 4 is negative 8. Do they both work? Now that's interesting. Take 0, plug it back in. 0 plus 4. 4 squared. 16 minus 5. That's 11. Take negative 8. Negative 8 plus 4. Negative 4 squared. 16. 16 minus 5 is 11. So they both work. It's a neat technique.
I wouldn't call it neat.
Yeah, most people don't like it when the plus or minus part is a rational number. They like it better when it's like a square root, because then they don't have to worry about it too much. But when it's a real number, a rational number like that, you have to what? No.
Is it not?
No.
You have to pass out a test.
I know, isn't that horrible?
I need time for that.
Tell her to get her school retake.
Okay. Last one. The idea here is it a perfect square equation? How do you determine? If the variable is
Squared.
inside those parentheses and squared, and that variable does not show up anywhere else. For instance, if this was 4x, all of a sudden that's not a perfect square equation. It has to be the x is inside of the square, and everything on the outside is just a bunch of numbers, constants.
So this would be considered a perfect.
It is a perfect square equation. But once I put a 4x over here, it's not a perfect square equation anymore. All the x's have to be inside the parentheses.
Okay.
Or the only x that you see is squared. There are no linear factors, x or things like that. All right, so what should I do first?
Subtract 7.
What's that called? What are we trying to do?
Distribute.
No, you don't distribute. You can't distribute 3 and 3 here. The
Call
power
it-
has to happen
Call
first.
subtract it.
But what are we trying to accomplish? Instead of what are the
Trying to
steps?
get the,
Get that
square
perfect
root by
square by
itself.
itself.
Yeah.
It's not a square root, it's a perfect square.
Okay.
It's a perfect square. So we're going to subtract 7. So we'll get 3 times x minus 5 all squared is equal to
Negative 3.
negative 3. Then what?
Divide by 3.
Divide by 3 and we get x minus 5 still all squared is equal to negative 1. Negative 3 divided by positive 3 is negative 1. What do we do to both sides?
Square root 'em.
Square root them. This is actually a mental step, but sometimes it's better to write them in. What happens on the left?
Oh,
You have x minus 5. What happens on the right? What? Oh.
It's
What
I.
happens on the right?
I.
Nah, before I.
Negative 1.
What's more important than the answer to this
Plus-
problem?
plus or minus.
That plus or minus. So it's plus or minus,
Negative 1.
but the square root of negative 1 is I. Remember?
dealing with them.
Oh my gosh, yes. That's why I wanted to do this one, because yes, we're still dealing with them. How do I finish it off? Add 5 to both sides. So you get x is equal to 5 plus or minus I. Which is what kind of number? I don't know. What kind of number is it? What's it called? When I write negative 5 plus I, what kind of number is that? What is it? What'd you say, Tori? You didn't say anything? No.
That's what I'm.
Oh my gosh. A plus BI. What kind of number is that?
It's BS.
It's imaginary, but it's got a better name.
It's not BI.
Begins with a C.
Confusing.
C-O.
Coefficients.
C-O-M.
Complex.
Complex. It's called a complex number. So what are the two answers here?
5
Confusing.
I.
5 plus I
5 minus I.
and 5 minus I. Good Lord, tomorrow's less 0. All right, what you do first? Add 80. So you get 2x squared is equal to 80. Then what?
2x squared equals, you brought it
Divide by 2.
Divide by 2. You get x squared is equal to 40. All right, then what?
Take
X squared
X
Square root both sides. Now I'm not going to write it, so I'm just going to do it mentally. If I square root this, it just becomes x. If I square root 40, I get,
plus or negative.
you better do the plus or minus first before you touch anything else. Automatically plus or minus. The square root of 40. Now, is that the answer?
No.
No, because square root of
Gotta
40
break
can
it
break
down.
down. So 2 goes into 40 20 times, 2 goes into 20 10 times, 2 goes into 10 5 times, so you can pull out a 2 and leave behind 10. So this becomes x is equal to 2 square roots of 10 or negative 2 square roots of 10. One for the positive and one for
That's
the
why I
negative.
keep forgetting to break that down.
Yeah, you have to split it at the end because writing plus or minus is a shortcut. To get the answers, you have to break it up into 2 pieces.
If you square root before you divide,
You mean up here?
yeah.
Alright. Let's say you square root way up here. You can do it, but it's got awful messy. You square root both sides. I want to write it in this time. You're going to get the square root of 2x squared. Does it simplify?
Mm.
Yes, you can pull out an x. Because there's 2 factors of x, right?
Oh.
But once you pull out the factor of x, what's left behind is the square root of 2, and then that'll equal plus or minus the square root of 80. It just gets messier. Because then you have to divide by the square root of 2, and then that'll become the square root of 40 eventually, but that's just a lot of extra work. And there's too many mistakes that can be made right here.
Yeah.
Yeah, in this little, that's the worst place for it. So get the square isolated, totally by itself.
Okay.
What was the other one?
Number 21.
21. It's the same thing.
Yeah, but when you add both sides.
Why do you do that?
21, 2x squared minus 9 is equal to 0?
Yeah.
Okay. So you add the 9 across, you get 2x squared is equal to 9. You divide by 2, you get x squared is equal to 9 halves. That's perfectly fine. It's ugly, but it's perfectly fine. The problem happens when you square root both sides. So you square root both sides and you get x is equal to
Plus or minus.
plus or minus
Square root of 9.
the square root of 9 halves. What's wrong with that?
You can't do a square root.
You can't have a fraction under a square root. That's one of the rules of square roots. Cannot have a fraction under a square root, so what can I do?
Flip it.
Most
No.
of them are
Oh.
No. Split it first. Split it first. So it becomes square root of 9 over square root of 2. I like just doing that. So plus or minus the square root of 9 divided by the square root of 2. What's the square root of 9? 3. So this becomes plus or minus 3 over the square root of 2. Then to rationalize it, because you can't have a square root at the bottom, now you multiply top and bottom by
two.
square root of 2. Square root of 2. And when you do, you get down to the answer of x equals plus or minus 3 square roots of 2 over 2.
I skip steps all the time.
I know, and it's so dangerous because when you start skipping steps, you're leaving off huge pieces of information.